Electrical Machine 2 code EX501. In this lecture, we are going to discuss about the commutator action, or we can say action of a commutator. We have already discussed about how a rotating coil under the influence of magnetic flux produces electromotive force, and this electromotive force is responsible for the production of current across the electrical load. A commutator performs two important functions in a DC machine. The first one is to convert the alternating quantities to direct quantities or vice versa. And the second function is to keep the rotor or armature MMF stationary in space. The first commutator function of rectifying the alternating quantities in the armature winding to direct quantities at the output brushes of a DC generator can be explained using a split ring copper segment. Generally, the AC machine or a DC machine containing armature as a rotating part always produces AC. This AC voltage can be extracted directly from the terminals using slip rings. But in order to convert that AC quantity to DC quantity, slip rings are replaced by split rings. Generally, the slip rings or are directly connected with the armature terminals, and together they becomes the rotating path along with the coupled shaft. And at any moment, whatever the voltage waveform is generated across the coil is also obtained across the brush. Whereas when the ring is replaced by a split ring, then this creates a difference of voltage waveform that we obtained across the brushes as compared to the armature terminals. The positive half of the voltage are obtained across the brushes are same as that the voltage received across the armature terminals. VA dash is equal to VB1 B2. This is for the half cycle rotation. For another half cycle rotation, the armature changes its polarity, but the voltage picked by the brushes doesn't change its polarity. Rather, continue to increase in positive direction. In this way, we can understand that how the action of commutator should take place. The stator of the DC machine carries salient poles, which produces stationary air gap flux. For the development of electromagnetic torque, the armature MMF wave must also be stationary in space. The commutator in a DC machine carries out this second important function of rendering the armature MMF wave stationary in space in spite of armature rotation. In actual machine, DC machine, there are large number of coils and slots and the number of poles is usually greater than 2, except for small DC machines. Therefore, the DC machine illustration as given differs from a real machine, but it serves well in explaining the commutator action.